So I now want to do another integral obtained by differentiation, and this is the second one, so I've called it 2. And our integral is u equals integral from 0 to pi upon 2 log of 1 plus cos alpha cos x dx divided by cos x. So the first thing I'm going to do is differentiate that with respect to alpha, and let's see what that gives us. So that's pi upon 2 and 0. We have 1 over cos x there. And when you differentiate the logarithm, you get 1 plus cos alpha cos x on the bottom, and on the top you get minus cos x sine alpha dx. And that will become, the cos x's conveniently cancel out, becomes sine alpha dx over 1 plus cos alpha cos x. We have to invert the limits because of the minus sign. Now, I've dealt with an integral like this before, but just to give you a little bit of help here, we do this by using the substitution t equals tan x over 2. That's a fairly standard substitution, which you have probably seen before. And that transforms our integral into the following form. So du d alpha is transformed into this form here. I'll leave you to do the details because I've shown you how to start it off, and that will come down to 2 sine alpha dt over 1 plus cos alpha plus 1 minus cos alpha t squared. And our limits will of course change, and they will be 0 and 1. Now, this is a standard integral using the tan inverse bit. It's an inverse tan type integral, so that comes to 2 sine alpha and becomes 1 over square root 1 minus cos squared alpha tan inverse square root 1 minus cos alpha over 1 plus cos alpha t. And the limits are 0 and 1. Now, you can see that this bit here, 1 minus cos squared alpha, is sine squared alpha. And when you square root that, it becomes sine alpha, and that will cancel very conveniently with the sine alpha in the numerator. So we come down to 2 tan inverse tan alpha over 2t. Because we bit the square root sign here, using half-angle formulas, the bit under the square root sign becomes tan squared half of alpha, and when you take the square root, it of course just then becomes tan alpha over 2. Okay, so now we substitute in our limits. And when we substitute in the top limit, 0, t will be 0, so you'll have tan of 0, which is 0, and shift tan of 0 is still 0. So that is 0 minus, and then when we put in the 1, we'll get tan inverse tan alpha over 2, which is 2 or minus 2 times alpha over 2, which is minus alpha. So we now have du d alpha equal to minus alpha. So all that just comes down to minus alpha. And so, integrating, we get u equal to minus alpha squared over 2 plus a constant c. If you go back to the original integral u, you'll see that if I put alpha equal to pi upon 2, the integral just disappears. So, but u equals 0 when alpha is pi upon 2. This enables us to work out what c is. So c will be alpha squared upon 2, which is pi upon 2 all squared divided by 2, which is pi squared over 8. And so finally we have our answer that u is pi squared upon 8 minus alpha squared upon 2. And that completes it. Thank you for listening.